So let's talk about solving the most general form of a differential equation. Um, they're known as separable differential equations, and what's interesting about them is that you can just solve them easily by integration without any tricks. So if we look at an example of the most trivial separable differential equation, dy dx equals y, with the initial condition y of 0 equals 1. So this is what we would say a first order linear um, differential equation. And obviously the reason that we call it that is that we call it first order because the highest derivative is 1. And we say that it's linear because the coefficients are dependent. Well, the coefficients are not dependent um, on basically the solution itself. So this has a constant 1 and this has a constant 1 as well. So it's linear. And that's why we call it a first order linear differential equation. So if I look at this guy, dy dx equals y, and I multiply both sides by dx, basically this step is interesting because it seems like I treated this like a fraction, but it isn't. Basically, the reason why you can do this is because the way that derivatives are basically a limiting process. So in the limit, when you take both sides of this, it will work out. But I don't want people to think that this is a fraction because it's not. The way that this is okay to do is just it's an abusive notation, but it's based on the fact that the limiting process of this quantity will be correct. So if I divide both sides by y, I get dy divided by y equals 1 dx. So both sides, and this is sort of the point of separation as the variables, this side is the left side is a function of its derivative and y, and the other side, well, okay, I won't say the derivative, but it's infinitesimal, and it's basically the left side is dependent on dy and y, and the right hand side is dependent on 1 and dx. So as a result, you can just integrate both sides because both sides are homogeneous. So on the left hand side, we just get ln of y. And on the right hand side, we just get x plus a constant of integration. So you might be asking why I didn't have it. Why is there not a constant of integration over here? Well, you do get one from here, and you get one here, but I'll just say that the left-hand side was C1, the right-hand side was C2, so I'll just say C2 minus C1 equals C to make things easier. So if I look at ln of y equals x plus c, if I raise both sides to e, I get that y equals e to the x plus c. So y equals e to the x, e to the c. So we know that y of 0 equals 1. So y equals 1 times e to the c. Well, for this to equal 1, then that would indicate that c is equal to 0. So that basically means that our solution y equals e to the x. So is this a solution to our problem? Well, if we look at the problem dy dx equals y, if I look at d dx of y, which is equal to d dx of e to the x, which is equal to e to the x. So if our y equals e to the x and dy dx equals e to the x, then it is in case true that dy dx equals y. So that's the most trivial example of a separable differential equation. Until next time.